Hello everyone and welcome to another video with Mr. Math. Today we're solving a definite integral. Okay, let's read our problem. We have the integral from 0 to 5 to the of the absolute value of 2x minus 5 dx. Okay, before we start the problem, let's just clarify the integral from a to b of f of x dx is equivalent to the original function evaluated on b minus the original function evaluated on a. Now we have a special case here, which is the absolute value. So we need to remember that the absolute value has two types of behaviors. So when I write the absolute value of x, I know there are two behaviors. There's a positive behavior and a negative behavior. I would say the positive behavior happens when x is greater or equals than 0, and the negative behavior will happen when x is less than 0. Okay, we need to take this definition of the absolute value and just apply to our expression. So I'm gonna solve that just right here. Okay, so we have something like the absolute value of 2x minus 5, and we know that we have two behaviors. Okay, let's find that out. We have the positive behavior, which is 2x minus 5, when what is inside the absolute value, which is 2x minus 5, is greater or equal than 0. If we solve for x, we'll have plus 5 on both sides and then divided by 2. Then we'll have x greater or equals than 5 over 2. So then that means that we will have the negative behavior, which will be negative 2x plus 5, when we deny the condition of x greater or equals than 5 halves, which is x less than 5 halves. Now let's analyze our interval. Our interval of integration goes from 0 to 5. Okay, and we have something there, 5 halves, which is a 2.5, right? So we have a 5 halves here. What this is telling me is that from 0 to 5 halves, right, which is less than 5 halves, I have the negative behavior. And from 5 halves to actually positive infinity, but in this case only to 5, I have my positive behavior. So we need to basically break down our integral in these two pieces. So let's find that out. So we'll have something like the integral from 0 to 5 halves. Remember, from 0 to 5 halves, we have the negative behavior, which is negative 2x plus 5 dx, and then plus the integral from 5 halves to 5 of the positive behavior, which it was 2x minus 5 dx. Okay, take a second and just review what we have in there, because we're going to solve one by one and then we will just put those back together. Okay, so let's just start by integrating this and solving with the bounds. Negative 2x, the integral of that is negative 2x squared over 2 plus 5x. And this has to be evaluated from 0 to 5 halves. Plus, and then we have the integral of 2x, which is 2x squared over 2 minus 5x. And this is evaluated from 5 halves to 5. Okay, let's start solving each one of this. So on this case, we'll have negative 2 times 5 halves to the square. Oh, we can simplify this negative there and just have a negative here. So it will be the negative 2 and the 2 will cancel out, and we'll have only x squared. So it will be negative 5 halves to the square plus 5 times 5 halves minus, evaluated on 0. But what do we know about this? Because every one of these terms has an x, so the component on 0, 1 will disappear, okay? It will not give us any value. And this plus the integral, these two will disappear as well. So I will have 25, which is 5 to the square, minus 25, minus, this will be 5 halves to the square. Okay, yes, 5 times 5, 25, 5 to the square, 5 halves to the square, minus, in this case, we'll have minus 5 times 5 over 2. Okay, so on this case, we'll have negative 25 over 4 plus 25 over 2 plus, this is 0, and then we'll have just a negative of 25 over 4, right, minus 25 over 2. Okay, what do we have here? We have a negative 25, negative 25 over 4 plus 25 over 2, and then we'll have minus 25 over 4 plus 25 over 2. If we add the fractions with like denominators, we'll have negative 5 or negative 50 over 4 plus 50 over 2. And this will be equals to what? Negative 50 over 4, that will be negative 25 over 2 plus, this should be just 2, plus 50 over 2. And this is 25 over 2. And that should be our answer. Okay, thank you for watching. Remember to follow us on social media, send your questions, take a minute and check the problem. Remember, we had to first find the behavior of the absolute value, which is very important that we do, so before we process the integral here. Thank you again for watching, and don't forget to subscribe and send us your questions.